Hello everyone. Some of you had questions about activity 3.4 question 2, and so I decided to make a video and work through that problem with you. It's not the exact same problem. I've made some modifications to the numbers, so I'm not giving you the answer directly, but the method will be the same. It's essentially the same problem. Anytime we're working with a trigonometry problem like this, we want to start with a diagram. So let's start by doing that. So step 1, diagram and labels. And the question, we're told we're at the top of a building. We're going to call that point C. The angles of depression to two cars on the same straight road are 42 degrees and 63 degrees. So angle of depression is going to be measured from an invisible or imaginary horizontal line extending straight out. So let's choose that. So this will be our reference for the angles here. So 1 is going to be at 42 degrees. And this isn't entirely to scale, and that's okay. So let's call that car B. And I'll make a line to represent that line of sight. So angle of depression is 42 degrees. And the other one is going to be 63 degrees. So that's going to be for the closer car. And let's label that as well. That angle is 63 degrees. And right away, we do know the difference between the angles. So we can actually figure out the angle within the triangle as well. And that's going to be 42 to 63, 21 degrees. And is there anything else that we need to label? The cars are on the same side of the building and are 200 meters apart. So we know that this distance here is going to be 200 meters. We are asked to determine the height of the building, and we are asked to figure out how far each car is from the base of the building. So let's label a couple other points here. Let's call this point D, and I think we're okay there. So this is fine for an initial diagram, but it does get a little confusing if you're going to try to use this to do all your solving. It just has extra labels and clutter and stuff. And so I like to draw a cleaner diagram, and we'll also choose our method at this time as well. So let's call this 1B. This will be our new tidy diagram. We're dealing with two different triangles here. We're dealing with triangle CDA. I'm going to resketch that cleanly with the things that I know. Right angle triangle. So that gives us a hint. We're going to use primary trig ratios, SOHCAHTOA. Right angle triangle, DA. And what do we know about this so far? Not very much. I do know the angle down here actually though. Using alternate angle patterns, or sometimes we just call it, whoops, the Z pattern. This angle here and this angle here will be the same. So because this is 63 degrees, this will also be 63 degrees. So let's label that on our new tidy diagram here, 63 degrees. We are going to need to figure out the length of this side. We're actually going to be doing that first, and then later we'll find these distances as well. So this will be the height of the building, and this will be the distance from the building to the first car, car A. My other diagram is a non-right triangle. It's going to look something like this. And this is triangle CAB. And what do we know about this triangle? Well, I know this angle up here is 21 degrees. We know the length down here is 200 meters. And because of the alternate angle theorem, that Z pattern again, we can know that this angle here is the same as this angle here. So if that was 42 degrees, this will also be 42 degrees. We're trying to find this side here because these are actually the same. So basically I'm going to work on solving the non-right angle triangle, finding that side length, which I can then carry over to my right angle triangle and use primary trig ratios to figure out the rest. So I have my diagram, and then here we'll also do step 2, which is choose our method. So first of all, let's look at our non-right triangle. We know angle C, and we know side C across from it. That means I have a pair of information. Anytime I have a pair, I can use sine law. So this is going to be a sine law problem. And then Over here, we have a right triangle. The angle is given. We're going to be given figuring out some sides and stuff. So that's going to be primary trig ratios. So SOHCAHTOA. All right, let's go ahead and do some solving. So part 3, step 3, we're going to solve. We're working with sine law, and we're trying to figure out this unknown side here. And we know the opposing angle. So that's going to be side B that we're trying to find over sine B. And we know the pair of C. I strongly recommend always taking time to write out the general formula first. That way I know you've chosen the right method. And then even if you make a calculation error later on, you're at least on the right track. If you have everything else right and just get the final answer calculated wrong, I still give you like 8 out of 10. The method is much more important than just giving me the answer. In fact, if you just give me the answer, I'll either give you 0 or a maximum of 2 out of 10 because I didn't see your work. I don't know how you got the answer. I'm not going to show all my work because I'm going to run out of room here. But basically, B is going to equal side C, which is 200, times sine B, which is 42 degrees, over sine C, which is 21 degrees. And let's calculate real quick. 200 sine 42 over sine 21 is, and hopefully this goes well. I did not try this ahead of time. I have an answer key for the original version of the question. I have not actually worked out this new version yet. I'm going to pause the video for a moment and just rescale the pictures on the page so they fit better, and then we'll continue. Okay, so I didn't really change anything except to resize and move things around a little bit. Also, I'm just going to point out my workflow. Workflow is an important thing that I also watch and keep track of for your marks and stuff. Mostly just, I need to be able to read it. If I can't read it, it's wrong. If I can't find the final answer, it's wrong. So basically, I always try to work down, and then if I run out of room, I go over and start in a new column. So my workflow is basically going to look like this. Ideally, if it's something simple, you just go down once and have your answer at the end. But if we don't have enough room, try to keep it in columns. I'm not super picky about that, but if your workflow is like this, which I do see sometimes, please don't do that. All right, so we have solved for one side of our triangle, and that was our side B, which is here. And B is equal to X, that length that we were trying to find. So that length is going to be 373.4 meters. So now we can take a look at our right triangle right here. So I'm going to, I guess I don't need to resketch it, but we can write the number here, 373.4. And we need to find this side and this side. Let's choose the height first, which I just labeled Y. You could have called it H. It doesn't matter. Let's label our triangle in terms of hypotenuse, opposite, and adjacent. I recommend always taking time to do this. It only takes a few seconds and helps to ensure that you're choosing the correct ratio. So hypotenuse, this is the angle we're focusing on, so opposite's here, adjacent is down here. We are trying to find the opposite. We have the hypotenuse, so we're working with O and H, so we're going to use sine ratio here. I'm just going to delete my labels because I'm going to need to relabel it again in a minute. So sine theta equals O over H. We're writing out the whole ratio. Sine 63 degrees. Opposite was our Y value or our height that we're trying to find over hypotenuse, which was 373.4. You're going to solve this by multiplying both sides of the equation by 373.4 times sine 63. So our height is going to be 332.7 meters. Now we need to find that bottom part. We need to find this value here, the distance from the building to the first car. Let's just switch colors and let's label hypotenuse, opposite, adjacent. So now we know the hypotenuse and we're trying to find the adjacent side. So we're working with A and H, and so we're going to use cosine. Come on. So cosine theta equals A over H. Cosine 63 degrees. Adjacent was our distance that we're trying to find. So Z, remember that's the distance from the base of the building to the first car, over the length of my hypotenuse, which is 373.4. So the value for Z is going to be 373.4 times cosine 63, which gives us 169.5 meters. So now we're almost done. I know that this distance here is 169.5. We know the height is 332.7. And we just need to figure out this distance here. I'll zoom in actually so you can see that a little bit better. So now we just need to find the distance to the second car, and that's just going to be adding these two numbers together. So let's do that off to the side somewhere. So basically we started with diagrams, we labeled them, we chose our method, we worked through and solved, and now we have to actually finish any remaining calculations and state the answer to the question. So the distance from the base of the building, let's call it the distance from D to B, is going to be 169.5 plus 200, which is going to be 369.5 meters. Always go back to the question at the end and make sure you've actually answered it. Sometimes you get lost in the calculations and maybe you find the side and then you forget to use it to find missing angles or something. Some of you did that on some of the assignments, so just watch out for that. So A, height of the building, B, how far each car is from the base of the building. So therefore, anytime you have a word problem, we should have a concluding statement, including units. Therefore, building height is 332. We'll just round to the nearest whole number for now to save a little room here. 333 meters. Car A is 170 meters from building. And car B is 370 meters away. So that is conceptually how to answer this question. This is kind of workflow and labeling and way to lay out your question and the amount of work that I would like to see overall. Some of you did find a shortcut method for solving this. That's fine, but I need to know where it came from. So if you're suddenly using new methods that are not included in the course, you either need to tell me how you discovered that on your own. So, oh, I realized I could sub this into this and solve and simplify. But that doesn't happen a lot. Sometimes you've done research of some kind and found the answer somewhere or found the formula. As long as you're still doing the work yourself, I don't have a problem with that if you're using an alternate method, but I need to know where it came from. Anytime you're using work that is not figured out by yourself or like straight from the textbook, that is a form of plagiarism. You can't just suddenly have the answer or suddenly have a brand new method that you didn't figure out without saying where it came from. So if you're willing to give me a source, or if you're going to do that, you have to give me a source and say, I found this using this. And even then, you're not supposed to have external help on the assignments. So if you want to do that for practice, that's fine. But on an actual assignment, I need to see what you know and what you understand, not what your tutor or your friend or your brother or ChatGPT or Chegg or the internet or whatever else was able to give you for an answer. Because we're online, I can't always verify that. But this is why I ask a lot of pointed questions sometimes, because I need to know that you actually understand what you're doing, because I want to give you the mark, not give a mark for what ChatGPT understands. I think we're doing okay overall. Feel free to keep reaching out and asking questions right away. I usually manage to respond within the same day. And overall, good work, everyone. Thanks.